once you know it, it's easy to understand. Okay. So here's the hypothesis. The hypothesis is it's all to do with a process known as ammonification. Ammonification is the recycling of nutrients from the seabed. Okay? So the first thing that you need for this process to actually work is you need to have a source of detritus accumulating on the seafloor. Detritus is dead organic matter. And the upwelling does that. The summertime upwelling of nutrients and the phytoplankton blooms that you get during the normal upwelling season produces organic matter. It dies off, it sinks and settles on the seafloor. Another source is indeed nutrients, are anything coming from rivers in terms of organic matter. Okay? So bacteria can then decompose these detritus in seafloor sediments and recycle it as ammonia. So now how you get it back from the seafloor into the water column is a process called erosion. So you need a very strong, we call it a shear stress, a very strong current running along the seabed that is strong enough to mix up all the top layer of the sediment. Okay. However, we know that from coastal oceans, such high bed shear stresses that you need there, they rarely exist. Okay, and there's a number here. You need something exceeding 0.3 of Pascal. And in terms of Pascal, it's much stronger than this 0.3 Pascal is much stronger than any wind can create. A very, very strong bed shear stress. And now the question is whether upwelling or downwelling favorable winds can create such extreme bed shear. It's about the friction of currents with the seafloor. Okay, and I just want to illustrate the difference between upwelling and downwelling, and again using a computer-based simulations with a model, with a hydrodynamic model, just to illustrate what happens.